All right, today we're going to pull back the curtain on a piece of technology that you've almost definitely used in the last hour, but I'm willing to bet you've never even heard of it. It's this invisible engine that keeps huge parts of the internet from just grinding to a halt. So let's dive in.
So, let me ask you a question. What do some of the biggest websites on the planet, we're talking Facebook, Twitter, Reddit, what do they all have in common? Now, the obvious answer is, well, they're all social media platforms. And yeah, you're right, but that's not what I'm getting at. The real technical answer is actually something way more interesting.
Turns out they all depend on this foundational piece of software that was created way back in 2003. It's a system called Memcached, and honestly, without it, a lot of these sites just couldn't handle the fire hose of traffic they get every single day. So what was the problem that was so big it needed a brand new invention just to solve it?
To really get why Memcached was such a game changer, we first have to understand a problem that every single popular website eventually runs into. You can think of it like a massive digital traffic jam.
And this traffic jam, it has a name: the database bottleneck. You see, all the important stuff for a website, all the user profiles, the posts, the comments, it all lives in a database. And that database usually stores its information on physical disks. Now, even fast SSDs are way slower than memory. So when you have millions of people all trying to read that data at the same time, the database just can't keep up. It becomes the single point of failure for the entire site.
This exact problem created a full-blown crisis at an early social media site, and it was that crisis that actually gave birth to the solution we're talking about today.
Okay, so picture this. It's 2003, and a programmer named Brad Fitzpatrick is running a site called LiveJournal. It's absolutely exploding in popularity, which sounds great, right? Well, it also meant the site was constantly slowing to a crawl and just crashing. He dug in and found the culprit. The MySQL database was getting hammered and couldn't handle it. He had to invent his way out of the problem.
And his idea? It was just brilliantly simple. He realized that most of the stuff people were asking for, popular posts or profiles, didn't really change that often. So instead of going to the slow database over and over again for the same information, he thought, why not just store the answers in something way faster, like the spare RAM, the memory that was just sitting there unused in his web server?
And that simple idea grew into Memcached. The best way to think about it is like a giant shared scratch pad for all of your web servers. So let's take a look at how this scratch pad is actually designed.
At its heart, Memcached is what's called a key value store. It's dead simple. It works just like a dictionary. You have a unique word, that's the key, something like user profile 123, and you have its definition, that's the value, all the actual profile data. This makes looking stuff up incredibly fast. There are no complex queries, it's just a simple, hey, get me the value for this key. Now, the architecture philosophy here is kind of genius. The Memcached servers themselves, they're intentionally dumb. They have no idea that other servers even exist. They just sit there, storing and retrieving data when they're told. All the intelligence, all the logic lives in the client, which is just your application's code. Your app is the one that decides, okay, this piece of data goes to server A, that piece goes to server B. This shared nothing design makes the whole system unbelievably simple and easy to grow.
And it's got a few clever tricks under the hood, too. First, everything is in memory. That's the secret to its speed. But it also means if a server restarts, poof, the data is gone. Second, it uses something called slab allocation. All that means is it pre-divides its memory into different size chunks, which stops things from getting messy and slow. And third, and this is really cool, when it runs out of space, it automatically kicks out the least recently used data. It's basically a self-cleaning system.
So how does an application actually use this thing? It follows a really common pattern called cache aside. Here's how it works. First, the app needs some data, so it asks Memcached. If Memcached has it, we call that a cache hit. It gets sent back instantly, awesome. If it's not there, a cache miss, then the app has to go to the slow database. It gets the data, and then, here's the most important part, it saves a copy of that data in Memcached on its way back to the user. That way, the next time someone asks for it, it'll be a super fast cache hit.
Okay, so this whole system works great for one server. But what happens when your website gets huge and you need way more caching capacity? How do you add more servers to this system without causing a complete and total catastrophe?
Because this, right here, is the absolute nightmare scenario. If you do it the simple way, adding just one new server to your pool completely changes the math for where every single piece of data is supposed to be stored. All of a sudden, every request is a cache miss. Your database gets hit with a tidal wave of requests it was never designed to handle, and the entire site just implodes. They call this a cache stampede.
The solution is this really elegant algorithm called consistent hashing. It's a super clever way of mapping data to servers. When you add or remove a server, only a tiny fraction of your data needs to find a new home. The vast majority of it stays exactly where it is, completely unaffected. This is the secret sauce that lets you grow and shrink a huge Memcached cluster without blowing up your whole website.
So, with this amazing solution for both speed and scaling, Memcached went on to become a fundamental building block of the web as we know it today. Let's just take a second to appreciate how big its impact really is.
It really all comes down to the 80-20 rule. You see, on most big websites, about 80% of the traffic is asking for only about 20% of the data. That's the hot stuff, right? A viral video, a celebrity's profile. Memcached is perfectly designed to serve that tiny slice of hot data from blazing fast RAM, which satisfies the huge majority of requests.
And how well does it work? I mean, in a lot of big companies, Memcached ends up absorbing over 90% of the read traffic. 90%! It acts like this massive shock absorber, shielding the database so it can focus on the much harder and more important job of safely writing new information.
So who's actually using this stuff? Well, the list is basically a who's who of the internet. Facebook, with its insane social graph, Twitter, with its constant fire hose of information, Reddit, Pinterest, Wikipedia, all of these giants were either built on or still lean heavily on Memcached to manage their incredible scale. It is truly one of the great unsung heroes of the modern web.
Now, some of you might be thinking, hey, what about Redis? And that's a great point. Redis is an amazing tool, and it has a lot more features, like saving data to disk and supporting complex data types. But Memcached radical simplicity and its multi-threaded design mean that for the one specific job of pure, blazing fast caching, it can still be the case.
And that really brings us to the end. Memcached is the perfect example of an invisible workhorse. It was a simple, powerful idea that solved a huge problem and basically enabled a whole new generation of the internet to be built. And it really makes you wonder, doesn't it? What other invisible technologies like this are out there, just silently humming along, keeping our entire digital world running every single day?